In this video, we are going to talk about derivative of trigonometric functions and also the derivative of the functions involving the combinations of trigonometric functions. So first we will look at the derivative of the basic trigonometric functions. For example, if we have y equal to sine x, then its derivative is cos x. If we have the function y equal to cos x, then its derivative is minus sine x. Just know that if a function is starting with c, let's say here it's cos x, then its derivative will have a negative sign. Then we have a function tan x, then its derivative is secant square x. If we have a function secant x, its derivative is secant x tan x. If we have a function cosecant x, its derivative is minus cosecant x cot x. Again, see here, cosecant x function is starting with c, so its derivative is giving you a negative sign. Then we have cot x function. This is starting with c, so its derivative will have a negative sign, and the derivative of cot x is minus cosecant square x. We will be using these derivatives to find the derivative of the function involving combination of these 6 trigonometric functions. Let's attempt a question. We have an expression y is equal to 1 plus sine cube, and the angle here is x to power 5 whole power 12. We have to find the derivative of this expression. To find the derivative of y, first we will write this expression y in a simplified form, which is 1 plus sine angle x to power 5, and this cube could be written as the whole power of this trigonometric function sine, and then the whole power is 12. Whenever there is the whole power on an expression and you have to find its derivative, you will start with the power rule of derivative. What does the power rule of derivative do? It brings the whole power on the side. Whatever is the expression inside the power, you write it as it is. 1 plus sine of the angle x to power 5 and then the whole power 3. So you subtract 1 from the power multiplied by whatever is the inside of the whole power, you calculate its derivative. Now the derivative for this inside term is derivative of 1, which is 0, plus now the derivative of this term, since this term has the whole power 3, so first you will apply the power rule, which is 3 inside term as it is, 3 minus 1 inside term is sine x to power 5, and then the derivative of the inside term is sine x5. So derivative of sine is cos of the same angle multiplied by angle's derivative. Since angle is x to power 5, so its derivative is 5x to power 4. Just know that if you have, let's say, the function cos 2x and you have to find its derivative. So first the derivative of cos is minus sine of the same angle, and then the angle's derivative, since the angle is 2x, its derivative is 2. So this is how you find the derivative of the trigonometric function. Now we have found the derivative, but we can simplify this expression. We will write 12 1 plus whole power 3. Inside we have sine x to power 5 and this whole power is 11. Then we have, let's multiply this 3 with this 5. 5 3 the 15 x to power 4 sine angle is x to power 5 whole power is square into cos angle is x to power 5. So that's how we find the derivative of this given expression y equal to 1 plus sine cube x to power 5 and the whole power is 12. Let's attempt one more question. We have an expression y is equal to square root. Inside the square root we have 3x minus sine square 4x, and we have to find the derivative of this expression. Before we find the derivative of this expression, we will write y in a simplified form. This whole power is 1 by 2. Square root can also be written as 1 by 2. And inside the whole power 1 by 2, we have the term 3x minus sine square 4x. Now for the derivative, since this expression y has the whole power, so first we will apply the power rule of the derivative. What does the power rule do? Power comes on the side, inside expression as it is, and then you subtract 1 from the power. Inside expression is 3x minus sine square 4x. After applying the power rule, whatever is the term inside the whole power, you calculate its derivative. So inside term is 3x minus sine square 4x. So first the derivative of 3x, constant is as it is, and the derivative of x is 1 minus sine square 4x. This square can also be taken as the whole power. Let's write sine 4x as the whole power. So its derivative by the power rule first, 2 into sine 4x, 2 minus 1 multiplied by derivative of the inside term, which is cos 4x, and then the derivative of the angle, which is 4x, its derivative is 4. Let's simplify this expression. It is 1 by 2 into 3x minus sine square 4x whole power minus 1 by 2 multiplied by 3 minus, now this 2 multiplies with this 4 gives you 8 into sine 4x into cos 4x. You can further simplify this expression and write it as 1 by 2 whole divided by this minus 1 by 2 comes down and becomes plus 1 by 2. Plus 1 by 2 is also the square root, so we can write it 3x minus sine square 4x square root into 3 minus 8 sine 4x cos 4x. That's the derivative of the given expression. Let's find the derivative of another expression. Here the question is y equal to x plus cosecant. Angle is x cube plus 3 and the whole power is minus 3. We have to find y dash. To find the derivative here, we can see that y expression has the whole power, which is minus 3. Whenever there is the whole power on an expression and we have to find its derivative, we can start by applying the power rule. What does the power rule do? It brings the power on the side, inside expression as it is, and subtract 1 from the power, and then the derivative of the inside term, which is this. So the derivative of x is 1 plus, since cosecant derivative is minus cosecant x cot x minus cosecant, but the angle here is not x but x cube plus 3. So we will write minus cosecant angle cot angle, and then the derivative of this angle. Angle here is x cube, its derivative is 3x square plus derivative of 3, which is 0. So we will not write it. Let's simplify this expression. it is, let's simplify this expression. It is minus 3 x plus cosecant x cube plus 3 minus 4. Here we have 1 minus 3x square cosecant x cube plus 3 cot x cube plus 3. You can further simplify this expression by writing it as minus 3 divided by x plus cosecant x cube plus 3 whole power 4, and this expression 1 minus 3x square cosecant x cube plus 3 cot x cube plus 3. So this is how we find the derivative of the given expression y. Let's attempt another question. We have to find the derivative of the expression y is equal to 2 secant square x to power 7, and we have to find its derivative. Before we find the derivative, let's rewrite this expression y as 2 secant, angle is x to power 7, and this power 2 on secant could be written as the whole power. Just remember that whenever on a trigonometric function there is a positive power, you can write it as sine x whole power. But whenever there is a negative power on a trigonometric function, it cannot be written as sine x of the whole power as minus 1, because this sine inverse x is usually written for the inverse trigonometric function. So just remember that whenever there is a positive power in a trigonometric function, it could be written as the whole power. So back to our question, we are finding the derivative of the expression y is equal to secant x to power 7. The whole power is 2. Since there is the whole power, so first we will apply the power rule of the derivative. We keep this constant 2 on the side as it is and then apply the power rule here. So power rule says bring this 2 on the side, secant angle, subtract 1 from the power, multiplied by derivative of this inside term. Now this inside term is secant of the angle. Derivative of secant is secant x tan x, but here we don't have x as the angle, we have the angle x to power 7. So we will write secant angle tan angle, and then the derivative of the angle, which is 7 into x to power 6. Let's simplify this expression. So we have 4, this 7, 4 into 7 secant x to power 7, 2 minus 1 is 1 into secant x to power 7 tan x to power 7, and this x to power 6 let's write here. So we have y dash is equal to 28 x to power 6, this secant x and this secant x, let's write it as secant square x to power 7 into tan x to power 7. So we have found the derivative of y equal to 2 secant square x to power 7. Let's find the derivative of an expression y is equal to x square plus x to power 5 into sine to power 8x, and we have to find the derivative. Before we find the derivative, let's rewrite the expression y x square plus x to power 5 into sine x to whole power 8. Again here 8 is the positive power in a trigonometric function, which could be written as the whole power. Now we have to find the derivative of this expression y. We can see that two terms are being multiplied, Let's call this as the first term and this as the second term, and we are going to apply the product rule of the derivative. Product rule of the derivative is applied when two expressions are being multiplied and we have to find the derivative. So how does the product rule work? It says first term as it is and the derivative of the second term. Since the second term is sin x to whole power 8, so first we will apply the power rule. 8 inside term, 8 minus 1, derivative of the inside term which is sin x. Sin x derivative is cos x. Plus, back to the power rule. First term as it is, second term derivative. Now the first term derivative. First term is x square plus x to whole power 5. So first we will apply the power rule. 5 into x square plus x, 5 minus 1, derivative of the inside term which is 2x plus 1, and the second term as it is, which is sin x to power 8. Let's simplify this expression. So we have 8 x to power 2 plus x to power 5 sin x whole power 7 cos x plus 5 x square plus x to power 4 into 2x plus 1 sin x to whole power 8. So we have found the derivative of the expression y is equal to x square plus x to whole power 5 into sin x to power 8. Let's attempt one more question where we have to find the derivative of y, which is x multiplied by tan 1 over x, and we have to find its derivative. Let's find the derivative. We can see that here y is written as the multiplication of two terms. So we will call x as the first term and tan 1 over x as the second term. So derivative will be found by the product rule. What does the product rule do? First term as it is, derivative of the second term. Second term is tan 1 over x. So derivative of tan is secant square angle. Here the angle is 1 over x. So derivative of tan 1 over x is secant square angle, and then angle's derivative. Angle is 1 over x. We have to find its derivative. We can write it as x to power minus 1, and then its derivative is by power rule minus x minus 1 minus 1, which is minus x to power minus 2. And when we simplify, it could be written as minus 1 over x square. So back to the product rule. First term as it is, derivative of the second term, which is tan 1 over x. Its derivative is secant square 1 over x, and then the derivative of the angle. Here angle is 1 over x, so its derivative is minus 1 over x square. Plus first term derivative. Here first term is x, its derivative is 1, and the second term as it is. Let's simplify this expression. So we have this x cancels out with this 1x, and we have minus 1 over x secant square 1 over x plus tan 1 over x. And we are done here. So this is how we find the derivative of the trigonometric functions and the functions that involve the combination of the trigonometric functions by using different rules of derivative like product rule, quotient rule, or the power rule.